Hello everyone, this is lecture 15 of PEC. We will discuss the equivalent resistance of arbitrary two-terminal network. Before the content, we need to introduce that if the two-terminal network contains dependent sources, how can we deal with it? For such a network, it has two terminals. If it contains resistors only, we can analyze it using the three methods we discussed previously, but sometimes it contains all kinds of dependent sources, so the situation becomes complicated. The serial parallel connection we have introduced previously and the balanced bridge and Y-delta transformation cannot deal with these two components. But through the study, we can find that U equals to Watt times I for this two-terminal network, and this Watt is Req. This reminds us the core of finding the equivalent resistance or port resistance of two-terminal network is to write out UI relationship on the port. So for the two-terminal network containing dependent sources, we can write the port characteristics with KCL, KVL, and component constraint, and find out Req accordingly. This is to say, though we don't know the port voltage and current, we can assume that there is a voltage and find out the corresponding unknown current, or in turn, assuming that there is a current and then find out the unknown voltage. We call these two methods U2I and I2U respectively. Next, let's look at an example. This is a two-terminal network. There are two parallel branches in a sub-circuit. Obviously, by writing KCL on the node, we get I equals beta I plus U over R. This equation needs to be listed no matter which kind of methods to be used. Next, we discuss it using two methods respectively. The first is U2I method. That is to say, current is expressed by voltage. I equals U over R times 1 minus beta for this circuit. The second is I2U method. That is to say, voltage is expressed by current. It can be written as U equals R times 1 minus beta times I. For these two equations, we can see that the upper is equivalent to I equals U over Req. The lower is equivalent to U equals Req times I. In any case, Req equals R times 1 minus beta. So the analysis of the problem is completed. We can see from the solution of this problem that this method can be expanded. That is to say, for any two-terminal network containing dependent sources and resistors only, we can calculate its port equivalent resistance with the method U2I or I2U. Next, we make a general discussion. We have introduced four methods in previous lectures. The first is serial parallel connection of the resistors. The second is a balanced bridge. The third is the Y-delta transformation. And the fourth is the method I2U and U2I. This should be noted that the first three methods are suitable only for the resistive two-terminal network, and we recommend you to choose them with the order from 1 to 2 to 3. That is to say, you'd better first check whether the network has a serial parallel connection relationship. If not, then try to find the balanced bridge. If not, transform it into the serial parallel connection with Y-delta transform. In other words, the order is like this. But for the two-terminal network containing dependent sources, we need to use the method U2I or I2U to solve it. Of course, for some special cases, we can only use U2I method or I2U method. We will discuss about it in the subsequent lectures. We can find out the equivalent resistance of any one-port network without independent sources by using these methods. Well, that's the end of this lecture.